Now that we have uh, written some code to get an LED to blink, let's expand on that. We've got pretty much the same code here as we did in the previous example when we used the built-in LED to flash, right? The biggest difference is that I'm now declaring a variable up top. And that variable is, so here you can see that I need to give it a type. So I'm saying this is an integer. So the LED pin variable is an integer and its value is 2. Uh, this is essentially saying that I'm going to be referring to pin 2 whenever I call LED pin throughout the rest of my sketch. I could also, if I wanted to make sure that I didn't want to accidentally change this, I could say const int, and that will turn this into a constant. So I would never be able to change this at any point in time in my code ever again. Um, this is a really safer way to do this. But the real takeaway here is like you need to, unlike in P5JS where you could just say like let something equal something. Here you need to say explicitly what your variable is going to be, what kind of thing it's going to be. So for the most part, dealing with microcontrollers, you'll be dealing with integers, sometimes which are whole numbers, right? They can go anywhere from negative 65,000 to positive 65,000, or even even greater if you're using something unsigned. Um, you can do floats, you can do longs, which are 32-bit numbers. You can do uh, characters, you can do strings, you could do booleans. You could even do floats, although it's not really recommended. But this is just to say that an integer or a byte, which is a value between 0 and 255, those are going to be the kinds of data types that you work with most in Arduino. So we're going to say int right here and be very happy with it. I'm going to leave that constant in there for completion's sake. And before I upload this, I'm going to build out my circuit. Now you'll notice here that I have added in these jumper wires from this bus row, these bus rows over here to these bus rows over here. And that's so that I can get power and ground over to this side, because I'm going to actually be building my circuit out over here. Pin 2 is this one adjacent to the ground on this side. So I'm just going to be building my circuit off of this. Now, so all I need here is my LED that I'm going to be blinking. And I also want to have a resistor in there because these LEDs, if you supply them with too much voltage, they'll burn out. They generally, these LEDs that we're using, they want somewhere between like 1.4 to 2.2 volts. So the 3.3 volts that we put out is too much for them. Uh, you can absolutely go down a rabbit hole and getting into specifics about this stuff. Please don't worry about it. For once, I'm going to say, just take me at my word, and take it on faith that this is what it's supposed to be. We can talk about the explicit sort of questions around this later, but it involves math, and who wants to deal with math when you can just plug stuff in, right? So I'm going to take one of my resistors. You'll notice that this one is orange, orange, brown. So this is one of those 330 ohm resistors. You should have 10 of them in your kit. Same one that you used for the LED previously when you're just building a circuit. So I'm going to take this, I'm going to connect one end of it to pin 2. The other end I'm just going to bring down, and I want to make sure that it's not in the same bus row as any of the other pins, the same in this orientation, in the same vertical column, right, as any other thing. Instead, what I'm going to do is I'm going to jump it from here, right, and I actually, yeah, so I'm going to jump it from here, pin 2, then I'm jumping it down here to this row, right? And so what I'm doing is now there's going to be a voltage drop across here. Now I can take my LED. Remember, you want to have the long leg facing power. So power is coming out of this, right? So I'm going to put the long leg here and the short leg in ground over here like that. And that is my circuit. Ta-da! It's awesome. I'm so excited. So now I'm going to plug this in. And again, you always want to make sure that you unplug everything before you build your circuit. I tend to build circuits first and then write code. But no matter what, I always make sure that the, the board is unplugged before I build anything. That just helps prevent shorts accidentally or anything of that sort. So now that I've got that plugged in, I'm going to upload my code and we'll wait for a moment. And once it's done, we should see this LED, the big blue LED. It's going to flash for 200ths of a. I need to press reset. So after I press reset, this will be on for 2/10ths of a second or a fifth of a second, and then it'll be off for 4/10ths of a second, right? So I'm going to press this, and then there you go. Now you can see it blinking. This is exciting. We've built a circuit, we can control it. This is awesome. Now, the next step here, this is called digital output, right? You've built a circuit, you can control stuff. The next step will be doing digital input. So we'll wire up a switch next. It requires a different kind of resistor and a few more wires and a little bit more code, but we'll use the switch to control the status of our LED next. But yeah, good luck with this, and yeah, that'll be good.